Hey everyone, and welcome to our lesson on conjugates of complex numbers. When you think about conjugates of a complex number, you can sort of think of the opposite of the thing that you see, the expression that you see. For example, if I see an expression a plus bi, a complex number in this form, the conjugate of that is going to be a minus bi. So I'm just going to change that symbol in the middle. We might come across things of this form, or we may come across things that only have one or the other part, just the real or the imaginary part, and we may be asked to find the conjugate. So we're going to take a look at examples showing all of those forms. Basically, if you have both parts, you're going to take the opposite symbol in the middle. A plus bi, remember, is going to be a minus bi. If you just have a plain number, a is just representing any number here, there is no conjugate for that because this is not a complex number, it's just a real number. So it's just going to be itself again. And then if you come across just an imaginary part, such as a number with an I, we're going to take the opposite of that number, keep the I. Here are some examples with some real numbers to make it easier to see. So at the top here, I've got 2 plus 3i. The conjugate of that expression would be 2 minus 3i, as we talked about. If it started off with a minus in the expression 8 minus 7i, then the conjugate will be 8 plus 7i. If I just have an imaginary part, so we're looking at this third one down here, 5i, the conjugate will be minus 5i. And the reason for that is because if I express this 5i as a whole complex number with a real part and an imaginary part, I would fill in a 0 for the real part. So using the same thought process from above, 0 plus 5i, the conjugate would be 0 minus 5i, and that's why we just can change the sign of the imaginary part. Alright, and then down here, our plain number 4, there is no conjugate for him because just a real number would be written as 4 plus 0i. And if I wanted the conjugate, I would have 4 minus 0i, but it's still 4. I'm not adding or taking away anything when I'm adding or subtracting 0i. So still 4. Those are just some real examples of finding the conjugates. Now the reason why you're going to need these is because you're going to have to use conjugates in division of complex numbers. The conjugate is used to solve and simplify those. So one thing that you're going to see happen in these solutions of these problems is the multiplication of a lot of complex numbers. When you take a complex number and its conjugate and you multiply those, the product will always be a squared plus b squared, and I'm talking about this a here and this b here. And I'm going to show you why. The reason for that is because when we multiply these, when we FOIL these, taking the first, outer, inner, and last products, I want to show you what happens. Let's take our a's, a times a, and this is just any number. A is representing any number. We'll have a squared. And then a times negative bi, negative a bi, and then our inner product bi times a bia. These are like terms here because I've got all the same letters in these terms. And then the last bi times negative bi gives us negative bi squared, which is b squared I squared. Okay. And every time we see an I squared, we're going to replace that with negative 1. That is the value for I squared, negative 1. So I'm going to go ahead and replace that. So simplifying this, the two middle terms here are going to cancel each other out because they are like terms, one's positive, one's negative. So dropping everything else down, I'm ending with a squared minus b times negative 1. Which is, minus b squared times negative 1, which is a squared plus b squared. So that's always going to happen. You can use that fact to shorten your work a little bit when you're seeing that you're multiplying a number and its conjugate. Alright, so how do we use conjugates in these division problems? what we're going to do is we're going to take the conjugate of the denominator and we're going to multiply it by both the numerator and the denominator that we see in the problem. So let's take a look at this example. We're going to divide 6 minus 4i divided by 2 plus I. And remember that we have to use the conjugate of the denominator. So when you see this plus sign in the denominator, we're going to be using a minus instead. So on the next screen, I'm going to rewrite this since we have quite a lot of multiplication to do. And I'm going to show you those steps. We've got 6 minus 4i over 2 plus I. That was the original problem. And we're going to attach 2 minus I on the top and the bottom here. And we're going to use the FOIL method for multiplying these out. That is the first, outer, inner, and last terms. So doing that, we're going to have 12, and then 6 times negative I. Then we got to do our inner terms, minus 8i, and last, plus, you can see these two negatives become a positive now, 4i squared. Alright, and on the bottom, remember we talked about earlier that we only need to do the first 2 terms and the last 2 terms here because the middle 2 are going to cancel out, the middle 2 of that FOIL method. So I'm going to do the first 2, which is going to give me 4, and the last 2, minus I squared. And now we just need to see what can come together, look at our like terms, and simplify until we have our simplified answer. Every time you see an I squared, we're going to replace that with a negative 1 because the value of I squared is negative 1. So we can go ahead and do that before we rewrite. Get those in there. And now let's come rewrite our numerator and denominator. So we now have 12 minus 6i minus 8i minus 4. That becomes minus 4. On the denominator, we've got 4 plus 1. Alright, we're scanning over for like terms now. So let's identify those. So we've got these i's that can come together right there. And then we have our regular numbers that can come together. So we're going to have 8 minus 14i. On the bottom, those can both go together. So I've got 5. And we can leave our answer in this form, or we can split this up into the real part and the imaginary part. If you wanted to do that, we would just separate these 2 terms over that 5 and have 8 over 5 minus 14 over 5i. And there we have it. Let's take a look at one more example, just to make sure we have this process going really good. Remember, to divide, we're going to use the conjugate of the denominator, which is going to be 1 minus 3i, because what we see there is a 1 plus 3i. We don't have quite so much multiplication to do in the numerator this time. We just have one number to distribute. So taking that across, let's take a look. We'll have 3 minus 9i up top. And remember, we can just do our first terms and our last terms on the bottom. So we'll have 1 minus 9i squared when we do that, these two here. Every time you see an I squared, we can replace that with a negative 1. We can go ahead and do that. Rewrite what we have, and we'll see if anything else needs to be simplified. Alright, so on the bottom here, excuse me, that should be a 9. On the bottom here, 1 plus 9 is going to come together and become 10. And I've got nothing that can go together in the numerator. So remember, we can leave our answer in this form, or we can split it up into the real part separate from the imaginary part, which would look like this. And we are all finished. There is nothing more we can simplify. So this concludes our lesson on conjugates of complex numbers.